Crises of Humanity, Chapter 3, Global Warming and the Survival of the Ice. Global warming and sea level increase from the perspective of the density of carbon dioxide and air temperature. This chapter outlines the current global warming situation based on premises that the density of carbon dioxide, air temperature, and sea level are all interlocked with a time lag. The Earth's climate has been warming up, mainly due to carbon dioxide emitted by human beings, and the ice on the Earth starting to melt. White snow and ice are acting as the Earth's mirrors to reflect the solar heat. As the areas covered by the snow or ice shrink, the amount of the solar heat reflected back to space decreases. The air temperature rises due to this effect, and the reduced volume of the ice. As a result, the sea level rises due to the melted ice above the sea level, plus the bloat of the seawater itself. Reflecting back to ancient times, the Earth, which had been void of ice for some time, had started to cool around 50 million years ago, and the ice piled up first on Antarctica, approximately 35 million years ago. The density of carbon dioxide was approximately 450 parts per million. The air temperature was plus 4 to 5 degrees Celsius versus today, and the sea level was higher than the current level by approximately 70 meters. The Earth has continued to cool down since then, and the ice started to build up in the northern hemisphere around 3 million years ago. The estimated density of carbon dioxide was 340 parts per million. The air temperature was plus 2 to 3 degrees Celsius versus now, and the sea level at that point was higher by 25 meters. The air temperature kept declining through the cycles of cold and warm periods, which thickened the ice on the northern hemisphere. About 8,000 years ago, both the density of carbon dioxide and the air temperature reached and stabilized at the current level, the same as the sea level. The academic definition of a glacial age is the status in which large ice masses, called ice sheets, exist. Thus, we are now in a glacial age. Within a glacial age, there are two stages. That is to say, 1. Glacier stage that lasts approximately 100,000 years, and 2. Interglacial stage that is relatively mild but has ice, normally lasting 10,000 years. We are now in the late phase of an interglacial stage. Interglacial stages come between glacial stages every 100,000 years. Thanks to the advancement in scientific research technologies, the fluctuation data on the air temperature and density of carbon dioxide and sea level since approximately 400,000 years ago up until now can be obtained with a high degree of accuracy. Homo sapiens were born about 200,000 years ago during the two previous interglacial stages, and have survived two lengthy glacial stages. Though there are temperature fluctuations during interglacial stages, the highest temperature was about plus 1 degree Celsius versus now. Although the air temperature during an interglacial stage 130,000 years ago was plus 1 degree Celsius versus now, the sea level was 5 meters higher than the current level. This evidence tells us how high the sea level would rise if the air temperature were to rise 1 degree Celsius from the current level, and the result would be quite accurate thanks to the advancements in research data accuracy. During the glacial stages, the air temperature drops by approximately 5 degrees Celsius versus now, and the density of carbon dioxide declines to a level of about 170 parts per million. As a matter of fact, during the glacial stage 20,000 years ago, the Earth was frozen and the sea level was more than 100 meters lower than now. Evidence also indicates that virtually the entire territory that is now Canada was covered with the ice 2,000 to 3,000 meters thick. It takes a time span of thousands or even tens of thousands of years for the ice to get thicker, as the ice freezes through cycle of snow accumulation. Contrarily, at the end of glacial stages, when the air temperature rose, the ice rapidly melted, and the sea level rose 4 to 5 meters every 100 years. Inferring from this history, even if the predicted sea level rise reported at the recent IPCC global warming conferences is as little as less than 1 meter toward the end of the 21st century, the ice will keep melting at an accelerated speed, and the sea level would rise drastically. This ominous prediction is attested to by the fact that the predicted air temperature and rise in the sea level has been getting higher with every global warming conference's declaration. The threshold of the existence of the ice will be surpassed in 25 years. Targeted figures of global warming conferences. Reflecting back on the history of the Earth's atmosphere through a time span of 35 million years, roughly speaking, a 1 degree Celsius increase in the air temperature versus now will ultimately lead to 5 meters rise in the sea level. A 2 to 3 degrees Celsius increase would melt down all the ice in the northern hemisphere, and the sea level would rise by 25 meters. If the temperature rises more than 4 to 5 degrees Celsius, the ice in the Antarctica would melt away, and all the ice on the Earth would disappear. Then the sea level would rise by approximately 70 meters. This was the saga of the ice on the Earth. And in the modern age, the density of carbon dioxide was 340 parts per million in 1980. With this level of the carbon dioxide density, the air temperature gradually rises up to 2 to 3 degrees Celsius, which is the threshold for the survival of the ice in the northern hemisphere. Since those days, around 1980, mountainous glaciers started melting down tangibly, and as a matter of fact, the ice in the northern hemisphere is approaching the verge of extinction. At the moment, the ice on the North Pole has approximately halved, and the ice in Antarctica and Greenland has started melting. If all the ice in the northern hemisphere disappears, the sea level would rise by 25 meters. According to literature around 1980, the pollution generated by human beings' mass consumption had exceeded the Earth's purification capacity, which can be proven by the fact that living species started to be extinguished rapidly. I say again that the synchronicity of the emergence of 3 thresholds, that is to say, mass consumption, rapid extinction of species of organisms, and endurance of the ice in the northern hemisphere, was not a product of chance, but evidence that the Earth had reached a threshold of its capacity. In 2015, the density of carbon dioxide has surpassed 400 parts per million and keeps increasing 2 parts per million per annum, which will reach 450 parts per million by 2040, only 25 years to go. With regard to the perils of global warming, the first threshold we had faced, which human beings should not have exceeded, was the carbon dioxide density of 340 parts per million we encountered at around 1980. As a result, the ice in the northern hemisphere started melting down. The next peril waiting for us comes when the density of carbon dioxide surpasses 450 parts per million at around 2040. The abyss we will face is the Earth with a sea level approximately 70 meters higher than now, with no ice in sight. At the IPCC, environmental scientists issue future predictions, which is generally regarded as considerably modest. However, that could underestimate the real status, since the contents of the reports are established based on intergovernmental consensus and tend to reflect enterprises' intentions. This inference can be proven by the fact that reported figures are increasing each time. The same IPCC reported the prediction of 2.6 to 4.8 degrees Celsius increase in temperature by the end of 21st century. This fact suggests that the biosphere has entered an emergency situation. According to the IPCC's prediction, the sea level will rise less than 1 meter by the end of the century. Having said so, as the reported figures have been increasing each time, more than a 1 meter rise could be a more realistic prediction. The reports do not even refer to the situation in the 22nd century and thereafter. As I briefly touched on earlier, the history of the ice since 400,000 years ago is quite clear. I strongly urge all stakeholders to take counter-strategies based on history, not stick to their own interests or speculations, and postpone those actions that are only justified by self-serving logic or theories. Among those environmental counter-strategies, the most crucial one is to suppress the density of carbon dioxide with a target of maximum 340 parts per million. Even with that target, the air temperature would rise by 2 to 3 degrees Celsius, and the sea level would rise approximately more than 20 meters, and the ice in the northern hemisphere would virtually disappear. Since the first IPCC, a quarter century has already passed. While valid counter-strategies are still being postponed, and we will be facing an Earth with a carbon dioxide level of 450 parts per million within another quarter century. Still, the world does not seem to have any intention of stopping economic growth. In physics phenomena, thresholds exist which denote the points of no return. That is to say, once a phenomenon exceeds a certain point, the phenomenon has become irreversible, which is also applicable to the Earth's limitations. If 450 parts per million is the threshold for the Earth's capacity, once carbon dioxide has exceeded that density, it would continue to rise, synchronized with the air temperature, until the circulation of carbon stabilizes, even though the emission of carbon dioxide is halted at the threshold. This is like screeching to halt just a second before crash. How are the world leaders trying to react against such a situation? According to the outcome of the 2015 COP21, they have set a target of plus 1.5 to 2 degrees Celsius versus the period prior to the Industrial Revolution as the limit of the air temperature, and 450 parts per million as the density of carbon dioxide, the latter of which was not clearly declared though. Comparing these targets with the Earth's history, plus 2 degrees Celsius is equivalent to the age of 3 million years ago, when the ice in the northern hemisphere had just started building up, and the sea level was approximately 25 meters higher than the current level. Far worse, 450 parts per million is the density of carbon dioxide, which is equivalent to the degree in the period 35 million years ago, when there was no ice on the Earth and the sea level was 70 meters higher than the current level. From the viewpoint of the Earth's history, these targets seem to be incoherent. Are they products of political compromise? We can see through to the future the world leaders actually predict. That is to say, giving up on the survival of the ice in the northern hemisphere and accept the rise in the sea level by higher than 10 meters. Dr. James Hansen, a Harbinger scientist who delivered a stark warning on the crisis in the domain of climate change, initially had proposed a target of carbon dioxide at 450 parts per million, but reduced it to 350 parts per million later, and is currently warning that even a 2 degrees Celsius increase is dangerous. Density of carbon dioxide, air temperature, sea level, and the history of the ice. Chronological examinations might help us to comprehend the situation, and thus I will roughly sketch the history of the Earth and the activities of human beings. Due to space constraints, I have started the history after the extinction of dinosaurs, and the time frames contain a margin of error. The most impressive event in the history outlined below, which I came across while I was preparing the chronological chart, was the birth of us human beings. At the very last stretch, human beings were born as extremely feeble creatures. That very species, human being, has come to drastically alter the environment surrounding living creatures. 65 million years ago, an asteroid of 10-kilometer diameter crashed onto the Yucatan Peninsula. Dinosaurs that have flourished for about 150 million years, together with almost all other living creatures, became extinct. The ice did not exist on the Earth. Starting at 200 million years ago, the Gondwana continent had started cleaving, and its divided sections were drifting, and the drift of the existing continents continued during this age. Frictional heat, caused by the continental drifts, is associated with global warming. 50 million years ago, the density of carbon dioxide was approximately 1,400 parts per million. The air temperature was plus 10 degrees Celsius higher than now. The ice did not exist on the Earth. The air temperature at this time was one of the highest. Alligators were said to be living in what is now Alaska. In other words, the Arctic region was as hot as the tropical regions are today. But this was the turning point, and the Earth started cooling down as it headed toward the modern age. There are various hypotheses for the reason why the air temperature was idiosyncratically high. One dominant hypothesis attributes the cause to the interaction during the following process. The Indian subcontinent that had split off from the African continent drifted at high speed and crashed into current Eurasia. The drifting speed of the Indian subcontinent was exceptionally high, and the frictional heat caused by the drift melted down the methane that had been frozen on the undersea continental shelf. As a consequence, a massive amount of methane, which is known for its powerful greenhouse effect, was released into the air. This methane is said to have increased the air temperature at an unprecedented rapid pace. When the aftermath of the crash of the Indian subcontinent had died down, the density of methane and carbon dioxide gradually reduced. As a result, the air temperature had rapidly dropped by 35 million years ago, and thereafter it continued to decline toward the current mild climate. 35 million years ago, air temperature plus 5 degrees Celsius, and carbon dioxide density approximately 450 parts per million. After a long absence on the Earth, the ice started building up in Antarctica, but the ice existed in the Northern Hemisphere. In this way, the ice began its existence on the Earth after the turning point of 35 million years ago. With a carbon dioxide density of higher than 450 parts per million, no ice can exist on this Earth. 3 million years ago, air temperature dropped to as low as plus 2 degrees Celsius versus now. Estimated carbon dioxide density was 340 parts per million, and the ice started piling up in the northern hemisphere. Sea level was higher than the current level by 25 meters. The Earth kept gradually cooling down. The ice piled up in the mountainous areas, and the sea level dropped. Both Greenland and the Arctic Sea were covered by ice. The majority of publications define the Earth's entry into the glacial age at around this period. The glacial age can be divided into glacial stages that last almost 100,000 years, and the interglacial stage, in which the ice exists, but the climate is a little bit warmer than the glacial stage. The interglacial stages last about 10,000 years. At the moment, we are in the latter part of the interglacial stage and are supposed to enter the next glacial stage. However, the climate is heading in the opposite way, that is to say, global warming due to human beings' activities. Even within interglacial stages, there exist temperature fluctuations. As a matter of fact, there were some periods when the temperature was warmer than now. That is to say, the temperature was plus 1 degree Celsius versus now, and the sea level fluctuated between levels 2 to 5 meters higher than now. The density of carbon dioxide fluctuated between 280 parts per million in interglacial stages and 170 parts per million in glacial stages. At least within the last 400,000 years, the density has never exceeded 300 parts per million up until 20th century. In glacial stages, the air temperature plunged to minus 5 degrees Celsius versus now. There is a cycle of about 100,000 years between an interglacial stage and the next interglacial stage. This cycle is said to be caused by the fact that the Earth's orbit is not a perfect circle due to the axial tilt of the Earth and the influences of other Earth's gravity, mainly that of Jupiter. 200,000 years ago, the second previous interglacial stage, Homo sapiens were born. Homo neanderthalensis had been born slightly earlier, 130,000 years ago, the previous interglacial stage. Human beings probably started using fire around this time. The air temperature was plus 1 degree Celsius versus now, and the sea level was 5 meters higher than now. Evidence indicates that the sea level had risen by 2 to 3 meters in 50 years, which suggests where the current temperature increase is going to end up. 70,000 years ago, it is said that human beings already started to use languages. During the era, the Toba volcano on Sumatra had erupted and the air temperature plunged due to the dust cloud that shaded the sunlight. A dark, cold climate lasted incredibly for more than 5,000 years, and human beings were virtually annihilated. Only a few thousand human beings were said to have survived this era in the entire world. All the existing 7 billion human beings are the descendants of those few survivors. Another Homo neanderthalensis, another species under Homo, also had survived the period, but was annihilated several tens of thousands of years later. The scale of Toba's eruption was said to be 3,000 times larger than the 1980 Mount St. Helens eruption in the U.S. Note, I personally experienced the magnitude of the Mount St. Helens eruption as I was at a place only 150 kilometers northeast away from the volcano right after the eruption. The summit was blown off and the altitude of the mountain has lowered by almost 500 meters. The scale of Mount Toba's eruption, 3,000 times larger than the St. Helen, is beyond my imagination. 20,000 years ago. This period was in a glacier stage, and the temperature dropped to -5 degrees Celsius versus now. The thickness of the ice that covered what is currently Canadian territory was between 2,000 to 3,000 meters, and the sea level was more than 100 meters lower than the current level. Even a 5 degrees Celsius air temperature difference could change the Earth's environment so drastically. Canada's current rich water resources derive from the ice that accumulated deep underground. At the end of this glacial stage, the temperature had started rising as the Earth moved toward the interglacial period. When the sea level was getting higher due to the melting ice, Mongoloids passed through the Siberian tundra and crossed over the Bering Strait, then continued on by land on account of the lower sea level to the American continent. At the moment, the depth of the Bering Sea is approximately 50 meters. Reflecting back today, human beings have survived twice through long and harsh glacial periods. 10,000 years ago, world population was only a couple of million. Human beings discovered agriculture, an avenue for life different from other living creatures. 8,000 years ago, the sea level stopped rising, and it has remained at a stable level for 8,000 years, up until the modern age. As a matter of fact, such a lengthy stability in the sea level was historically extremely rare. Settlements had developed near seashores, and the stable sea level was a prerequisite for their existence. Large-scale agriculture had become feasible, and the population started to become concentrated. Surplus and/or predation had enabled settlements to grow into cities, and their population further increased. Human beings entered into recorded history tangibly shown in the antiquities exhibited in the British Museum. At around the advent of AD, human population, 100 to 200 million. Forests started diminishing due to usage of wood fuel and slash-and-burn farming. 1800 AD. Human population, 1 billion. Density of carbon dioxide was 280 parts per million. As population increased to the extent European forests could afford, the forest-dependent culture was taken over by the Industrial Revolution with its coal-dependent civilization. Both the steam engine and the electric light were invented in that era. 1900 AD. Human population, 1.5 billion. Reached 2 billion in 1927 AD. Advent of the aircraft. 1950 AD. Human population, 2.5 billion. Advent of oil-dependent civilization and the era of mass consumption. Japan surrendered in 1945. First commercial nuclear reactors started operations. 1960 AD. Human population, 3 billion. Advent of the jetliner. Mass transportation of goods by gigantic oil tankers commenced. Chemical substances, smoke and soot, pollution in rivers and oceans started drawing people's attention. A red signal came on against the economic growth. 1970 AD. Human population, 3.7 billion. Oil shock. Controversy about global environmental issues spread. 1980 AD. Human population 4.5 billion. The year when human beings' activities surpassed the threshold that the Earth could afford. Living species started decreasing rapidly. The ice in the northern hemisphere started melting. The density of carbon dioxide was 340 parts per million, which is the upper limit for the existence of the ice in the northern hemisphere. Around this time, the U.S. government drastically loosened up its progressive taxation scheme under the Reagan administration. The gap between the rich and the poor significantly widened. 2000 AD. Human population 6 billion. Carbon dioxide density 370 parts per million. The Gore versus Bush incident at the time of the U.S. presidential election became a noteworthy trial in thinking about the future of the global environment. The Kyoto Treaty that stipulated the rules on the reduction of greenhouse gases came into force in 2004. However, the treaty could not work as expected due to the defection of the U.S. under the Bush administration and China for the reason of disadvantaged impact on their economies, along with other countries' refusal to comply with the carbon dioxide reduction quota. 2013 AD, 7.15 billion human beings. IPCC announced its prediction for the temperature increase by the end of 21st century, 2.6 to 4.8 degrees Celsius versus 2000. Conservation ecologists announced that approximately 200 species of organisms are annihilated every day. According to them, this rate is hundreds, or according to some scientists, even 1,000 times faster than the last 5 extinction events. Without countermeasures, all species of organisms would be extinct within a couple of centuries. Having said so, in case human beings are annihilated before that, the situation might be different. Human beings are dependent on the lives of other living creatures in every aspect, including foodstuffs and drugs, etc. 2015 AD. Human population 7.3 billion. The density of carbon dioxide has exceeded 400 parts per million and is still rising by 2 parts per million per year. This can be considered an emergency situation. It may surpass 450 parts per million in 2040, 25 years from now. Once the density of carbon dioxide exceeds 450 parts per million, the air temperature would, in sync, increase by 5 degrees Celsius versus now. The sea level would also keep rising and ultimately reach approximately 70 meters higher than the current level. Super greenhouse gas methane. The major cause of global warming is the usage of fossil fuels, and the main agenda of global warming conferences is the reduction of carbon dioxide. However, on top of carbon dioxide, we should focus on methane gas, that is said to have a strong greenhouse effect 30 times more powerful than carbon dioxide. The majority of the methane existing on Earth, a quite gigantic volume, is still dormant and frozen under the continental shelves and/or in tundra. I am not very familiar with chemistry, but let me attempt an explanation. When the carcasses of living creatures deposited on the continental shelves and under the ground degrade, in case there is oxygen, carbon dioxide is generated. On the other hand, without oxygen, methane is generated. Methane frozen under the seabed or tundra is called methane hydrate. Therefore, once the temperature of the ocean and soil surrounding the methane hydrate rises, the methane evaporates into the atmosphere and becomes oxidized, which produces an intense greenhouse effect. Geothermal heat in the tundra area, permafrost soil, has risen, and the frozen methane starts evaporating. Warming of 1 degree Celsius at the equator denotes 3 degrees Celsius temperature rise in the Antarctic regions. Thus, it is easier for both the ice and the methane in those areas to melt or evaporate. Even though the Earth has a self-regulation function to maintain the density of carbon dioxide at a certain level, this function would become dysfunctional if the global warming progresses too fast due to human beings' overwhelming influence. Once the density of carbon dioxide exceeds a certain threshold, the air temperature would become uncontrollable, whatever counteractions human beings might take. A big problem now is the fact that human beings are trying to develop this methane hydrate dormant under the deep sea beds as their new energy resource. Considering the difficulty in preventing underground leakage into water supply systems, it may be impossible to prevent leakage of methane from the methane hydrate rigs. The effect of the leakage of methane is equivalent to carbon dioxide emissions of 30 times as much, which would accelerate the global warming in a burst of speed. Even though human beings face energy shortages for economic growth, consuming coal and dangerous methane that generate far more pollution to fulfill the shortage is absolutely absurd, considering the welfare of the forthcoming generations. As I introduced previously, the global environmental issue is not related to energy shortage, but has to do with the issue of residual pollution. Instead of shifting to coal, a combination of taxation scheme reformation, which deters consumption, and utilization of existing oil and associated facilities would be a more efficient way in terms of both pollution management and cost to recover a rich circulatory environment. I believe that is the shortest avenue to establishing a sustainable society. Earth's environment is drastically changing. Tangible change denotes 10,000 times fast-forward film from past history. We have a sense that an individual human being is a feeble existence and does not possess the power to influence Mother Nature. Having said so, human beings as a whole now possess a huge influence over the Earth through science and technologies. For example, expansion of large-scale machines, diffusion of industrial chemical substances after the Industrial Revolution, birth of mega enterprises, and mass production. Its population has quadrupled since the event of the 20th century, which has amplified the power of human beings by a factor of more than 10,000. Furthermore, we started utilizing nuclear power that is associated with the birth of stars. In particular, in the latter part of the century, when human beings entered the civilization of mass transportation utilizing oil, their influence over the Earth has become enormous. Within only half a century, human beings have significantly altered the shape of the atmosphere, oceans, mountains, and rivers, aiding the annihilation of species of organisms. I feel that amongst human beings an unconscious moral tone is prevailing that infers that even though we conquer nature and problems arise, we can solve those problems using our science and technology. This moral tone, combined with the freedom to be greedy, drove us to mass consumption. As a result, the Earth that used to be believed to possess infinite capacity has started transforming visibly, caused by human beings' influence. What kinds of transformation has the Earth experienced? Reflecting back on its life, one significant transformation was the drift of continents. There used to be only one supercontinent on the Earth prior to 200 million years ago, which then split and drifted to become the existing continents. The existing continents are said to have drifted and then gathered to form a supercontinent within a period of several 100 million years. Continents repetitively drift due to circulation of the Earth's mantle. What a magnificent romantic saga! Although the continent's drift is only a couple of centimeters per year, this cannot be observed by short-lived human beings. This is truly a gigantic transformation of the Earth. It takes a time span of tens of thousands or even hundreds of millions of years for the Earth to transform. This saga denotes that the recent visible transformations of the Earth that have occurred in the last 100 to 200 years, caused by human beings' mass consumption, were cataclysmic changes in its life. Even though those changes endanger living environments, to the eyes of the short-lived human beings, they look like only languid changes. Therefore, those changes do not trigger any sense of crisis, and days are passing by idyllically. Even though the changes look very slow, if those changes were visible, the changes would be explosive phenomena considering the lifespan of the Earth. The ice meltdown in the last couple of decades is indeed an explosive change, and the biosphere is now in an emergency situation. This is another piece of evidence that tells us that human beings' mass consumption has exceeded the Earth's capacity. What human beings are doing is turning back the history of the Earth. The air temperature that had cooled down by 4 to 5 degrees Celsius over 35 million years is returning to its original level within only a couple of centuries through global warming. In terms of the density of carbon dioxide in the air, human beings have caused it to change 2 parts per million per year, which Mother Nature had been changing at a pace of 2 parts per million per 10,000 years. Human beings' influence over the Earth is tens of thousands of times bigger than that of Mother Nature. How gigantic it is! This looks to me like a 10,000 times fast-forwarding film on the Earth's life. I clearly recall an article in which a great enterpriser said in the era of rapid growth 50 years ago, "If Japan needs more land, why don't we scrape against mountains to use the soil for reclamation? Young people should have these kinds of big, dynamic ideas." Intelligence, greed, science, and technologies that do not respect life have now turned into lethal weapons and are threatening not only human beings, but also the entire biosphere. The ice thaw current status. Based on the history of the ice's rise and fall, it used to be believed that it took thousands of years for alpine ice and/or ice sheets covering the Antarctic to melt down due to climate change. If that is the case, we can take our time to think about countermeasures. However, considering the recent situation, scientists have started thinking that the slow pace of the ice's fall is rather attributable to the fact that the natural temperature itself had been changing at a slow pace. The ice responds sensitively to the air temperature and melts down fast. Due to rapid rise in the air temperature since the advent of the 20th century, not only the ice on high mountains, the Arctic and Greenland, but also Antarctic ice sheets actually started melting at a visible pace. The Arctic ice has halved, and the ice on Greenland and the Antarctic started melting. Antarctic ice shelves that protrude onto the ocean started rapidly collapsing at around the year 2000. We can easily access visual images that show the alpine meltdown and the retreating ice. Puddles of water started appearing on the ice in Greenland. Photos showed the water flowing and creating holes in the ice sheets, and then vertically draining away into the holes. What's happening beneath the holes? Greenland's actual landscape is quite different from the white wedge shape shown on maps. Cartographs of the Arctic Ocean floor attached to aeronautical maps show a shape that resembles a human's left ear. About 30% of the lower left side of the white ice sheet consists of a big cove where the bottom of the ice sheet attaches to the ocean. As ice is sensitive to the sea temperature, it starts melting from the bottom part when the sea temperature rises. One of the significant points of the 2013 IPCC is its forecast that the air temperature would rise by between 2.6 and 4.8 degrees Celsius, and the sea level would rise less than 1 meter by the end of this century. However, the report does not refer to the following centuries. If the temperature rises by approximately 5 degrees Celsius, even if some of the ice would survive until the end of the century, virtually all of the ice on the Earth would disappear. The meltdown of all the ice ultimately means 70 meters rise in the sea level. This is nothing other than a cataclysmic event as far as the Earth's phenomena are concerned. Reflecting back on the saga of the ice on the Earth, that is highly likely to occur. Whilst ice melts down very quickly, it takes several thousands or even tens of thousands of years for the ice to regain its original thickness through the cycle of snowfall and meltdown. Damages caused by global warming. If the changes are not visible, human beings don't care and take no action. However, countermeasures taken only after the change has become visible are too late. Conceptually, the various circulations of the Earth synchronize every 20 to 30 years, which denotes that pollution would become visible only after spreading widely across the environment through the circulations. We can realize that the color of the water in a swimming pool has changed only after a large amount of ink has been poured into it. Earth's history suggests that 1 degree Celsius global warming denotes 5-meter rise in the sea level. Only 1 to 2 meters rise in the sea level would swallow islands and the megalopolises that develop on plains near the mouths of rivers or on seashores. Global maps that mark the predicted sea level rise by the unit of 1 meter would be a good reference for us as we work to establish future countermeasures. The reclaimed lands would sooner or later face their destinies, swallowed up by the sea. You can imagine the situation. A very slow tsunami hits and stays. Hundreds of millions or even billions of people who cannot live on islands and or plains or fields will become global warming refugees. They will cross borders and may cause riots. At the point such a situation occurs, the global economic or social systems may have already collapsed. I personally saw a picture showing houses caved in and roads interrupted due to the tundra melting. If a significant volume of methane contained under the tundra were released into the air, global warming would accelerate even more. Once the air temperature rises due to global warming, theoretically, water vapor in the air drastically increases. Increased vapor in the air would lead to increase in the volume of rainfall. When saturated vapor metamorphoses into clouds and rainfall, an enormous amount of latent energy is generated, which intensifies wind velocity, both vertical updrafts and downburst. cumulonimbus clouds become gigantic and cause phenomena such as the recent torrential rainfalls and/or heavy snow. Record-breaking meteorological events are increasing. As a matter of fact, typhoons are getting stronger, and tornadoes, something that had rarely been observed in Japan, have increased. Associated with those phenomena, mudslides and floods break out that destroy houses and cause complex sets of calamities, such as inundations and breaches of levees. Theoretically, the wind pressure increases at wind velocity squared, and roughly speaking, damage caused by a windstorm would increase by 40% when the wind velocity increases by 20%. Damage caused by weather anomalies is getting more and more disastrous, which could be proved by the amount of casualty insurance claims. In this aspect, I count on big business to tackle environmental issues in a more sincere manner. Even less than a 1 degree Celsius temperature rise is causing this devastating situation. As global warming advances, snowfall would no longer accumulate in the mountains. That leads directly to droughts in the summer. Even though changes in global meteorological patterns deteriorate living climates, people cannot move easily. What would happen if a homeowner has a 30-year mortgage? Entrance barriers for the countries with relatively good dwelling environments would become even higher. Mega projects that take a couple of decades to undertake would likely face the collapse of the global economic structure before completion. Even if they are lucky enough to reach completion, maintenance thereafter would be unaffordable. What will be the fate of the process and cost of nuclear reactor decommissioning that is said to take more than 40 years? At the risk of sounding importunate, the biggest damage to the mankind and the biosphere caused by global warming, shown by the Saga of the Earth, would be the scenario where a 5 degrees Celsius increase in the air temperature reverts the Earth back to the past 35 million years ago. The ice disappears from the Earth. The sea level rises by approximately 70 meters, and the situation would last tens of thousands of years. Living creatures that are not capable of adapting to a temperature rise of less than 1 degree Celsius, as the warming pace is too quick, are heading toward annihilation. At COP21, held in 2015, finally, after 21 efforts, a consensus has been reached. But I regret about the fact that human beings had already consumed several decades for nothing. An implicit understanding, if my country or ethnicity can survive, that would be fine, seems to have been fostered among the great world powers. Global warming and the drift of continents, Saga of Earth and human beings' influence. 165 million years ago, it was 100 million years older than the annihilation of dinosaurs. There was a supercontinent floating on the Earth's ocean. The supercontinent broke out and each part started drifting. It was like a disassembling jigsaw puzzle. The Americas broke off from the African, Eurasian continents. Hundreds of millions of years later, those continents coalesced again to form a supercontinent. What a saga of Earth! All substances in cosmos repetitively circulate and metamorphose along with the flow of an infinite number of elemental particles. This saga of drifting continents, as a matter of fact, is related to global warming. During the drama of the continental breakup, the Indian subcontinent split from Africa and drifted north at a pace of 20 centimeters per year, which was 10 times faster than the other continent's drifting speed. The reason for this high-speed shift was the relative thinness of its landmass. During the drift, Indian subcontinent produced an enormous volume of greenhouse gases. That is to say, methane and carbon dioxide, frozen on the seabed, melted due to the intense friction heat. Whilst the Indian subcontinent was crawling northbound like an animal, the greenhouse gases released into the atmosphere caused an acute rise in the air temperature. It was 55 million years ago when the air temperature surged instantaneously during this period of global warming, caused by the drift of the Indian subcontinent. This happening was named surge in global warming and attracts some scientists' interest. There are various hypotheses on the causes of this event. One of dominant hypotheses is there was a point on the seabed where a distinctively large amount of methane, a gas that possesses a greenhouse effect 30 times more powerful than carbon dioxide, had been dormant. When the Indian subcontinent passed over the point, the methane blew up. Whilst we call the surge a happening, the temperature rise was only 5 to 8 degrees Celsius, and that instant denotes thousands of years in the Earth's life. On the other hand, human beings are causing similar temperature increases, only within 1 century. Human beings' influence over the Earth overwhelms this happening. If human beings set off such drastic shock waves, the Earth's biosphere will never be able to maintain its security and peace. The Indian subcontinent advanced further northward, causing the air temperature rise, and crashed into the current Eurasian continent 50 million years ago. It crawled under Asia for as long as 2,000 kilometers from the seashore and upthrusted Eurasia. Thus the greater Himalayas were created. When the crash had halted, the reduction in the emission of methane and carbon dioxide ushered in the era of global cooling. As a result, the ice started building up in Antarctica 35 million years ago, for the first time after the lengthy warm period. Thereafter, the ice had appeared in the northern hemisphere 3 million years ago, and mild climates suitable for living creatures lasted up until the modern age. Then human beings came into the world, and now I'm here. I went mountain climbing all the way to Everest, which at that time was still tranquil. On a rocky ridge at 8,000 meters high, I encountered a yellowish geological layer in which a marine organism rested in peace. I can vividly recall myself thinking about the past, 50 million years ago, and listening to the creak derived from the bowels of the earth that bore the massive mountain. Even 1 millimeter upthrust per year would generate a mountain 8,000 meters high in 8 million years. I heard that the Himalayas are upthrusting even now, which is evidence that the Indian subcontinent has not completely halted its crawl under the ground. Human bonds, unprecedented heavy snow. In the last 10,000 years, the Earth's climate has been relatively stable. Scientists say it is quite rare in the Earth's history that the sea level stays stable for such a long period. There were the glacial stages in the last tens of thousands of years, when the temperature was lower than now by 5 degrees Celsius. The majority of the Earth's surface was snowed in, and the sea level was lower by 100 meters. Those stages were extremely harsh for living creatures. Since the dawn of its history, human beings have suffered from heavy snowfall, endured heat waves, and survived famine caused by the Earth's climate changes. I can imagine how our ancestors survived adversity and handed over life to the following generations. When I retired from my job as an airline pilot, Alpine glaciers, viewed from the stratosphere, had obviously retreated, and snow accumulation had decreased. I personally realized while I was flying that meteorological phenomena are getting more and more volatile. A decade had passed since my retirement, with which I sensed a crisis, climate change, and another decade has passed since I moved to a village in the bosom of beautiful mountains in Yamanashi. In 2 decades, environmental deterioration could have advanced substantially. However, I cannot sense any omen of climate change or meteorological havoc, as I personally spend my days surrounded by scenic beauty, where the 4 seasons are rotating handsomely. Although the media occasionally broadcasts scenes of heavy snow, floods, and tornadoes, it might be quite natural that ordinary people rarely possess a sense of crisis. In the mountain village where I live, we normally had only 2 or 3 snowfalls per year, and the snow never accumulated more than 20 to 30 centimeters. For us, snowfall meant one of the gifts given by the 4 seasons. However, in February 2014, an unprecedented heavy snowfall hit the calm mountain village. Transit was paralyzed, which made us realize the importance of rice as a non-perishable foodstuff. All the extra work I needed to do was to remove snow from my room's skylight window, as I was afraid of the window being broken due to the weight of the snow. Other than that, we had no emergency incidents, such as a blackout or disrupted water supply. I could have some 5 days of free time in my isolated home to think about various things. Even in an isolated home, I didn't feel lonely, with my heart warmed when I visualized the smiles of our neighbors and village folk and people who always cared about my wife's health condition. However, I thought about people who needed dialysis treatments but could not visit the hospital due to the paralyzed traffic. What I noticed while I was snowed in was that we could depend on the warmth of people's hearts. Currently, we feel it's quite normal to depend on public services in case of natural disasters. 1 week to 10 days of isolation could be okay. What we need to do is just simply live with some inconvenience during the period. However, if roads were impassable and the blackout was to continue for a month, some aged people living alone would starve to death or end up dying a solitary death. In such a situation, we acutely feel how dependent we are on the connection with the outside world to live. I could not see human figures. Only a scattering of houses could be seen in the snowy world. Ancient people surely needed to depend on human bonds, hearts yearning and caring for each other, to survive the harsh natural environment. The TV was broadcasting what actions the local governments were taking. From the interviewee's expression, I thought of the human bonds among solitary contemporary human beings. Such important bonds with dear, close people could be diluted through impersonal, monetary ones. As a matter of fact, there really exist people who are suffering from mental trauma. Those are the people who lost their human bonds and lived lonely lives in temporary housing built after the collapse of communities caused by the catastrophe of the massive earthquake and tsunami. As global warming advances, meteorological havoc will surely increase due to increased moisture vapor in the atmosphere. On top of the disaster contingency planning, immense costs incurred by countermeasures for environmental pollution and safety-related activities would deteriorate the social structure in which people depend on somebody due to budget shortages. A new era of ancient societies would be revived, where the closest people nestle up and depend on each other. I think of the human bonds between our ancestors who had depended on each other since hundreds of thousands of years ago and handed over life to the following generations. Earth and the fate of human beings. I thought that human beings would be able to survive as long as 5 billion years, the same as the lifespan of the Earth, if we live harmonized with the Earth. But maybe I was wrong. The Sun is said to heat up by 1% every 100 million years. When the Sun heats up, the Earth's feedback adjustment mechanism works to contain carbon dioxide on the inside of the Earth. If that is the case, after a couple of 100 million years from now, due to the lack of carbon dioxide in the atmosphere, existing living creatures, including human beings, dependent on photosynthesis, would not be immune to the fate of disappearance. At that stage, human beings could emit immense amounts of carbon dioxide into the air to compensate for the shortage of carbon. However, that means the Earth dashing toward a world as hot as hell through accelerating global warming. The history of living creatures that have survived 3.8 billion years would end within several 100 million years. If no living creatures exist on other Earths, life consisting of elementary particles would disappear from the universe. If the Sun further heats up, oceans on the Earth would evaporate. As the greenhouse effect of water vapor is intense, the Earth would be further warmed up, and all the carbon dioxide and methane contained within the Earth would be released into the atmosphere. Those gases surround the Earth and accelerate the global warming. Furthermore, water moisture would be decomposed and flow out into space. Water on the Earth would disappear, and its climate would become one identical to the perfervid Venus. The Sun heats up further and will start inflating. 5 billion years from now, the Sun would be 50% hotter than now and metamorphosed into a giant star that will swallow the Earth and cause it to evaporate. I, at that stage, have died, burned, and become sparse of molecules. I, who was part of the life on Earth, would be evaporated together with the Earth and embark on a voyage of circulation as gas within space. In a way, I am looking forward to that future. All the molecules derived from my beloved ones, people who cherished me and those who hated me, will embark on this voyage. This is not a fantasy, but the world of science. End of Chapter 3.